Okay, today we're going to be going through appendages of the skin. The two types of glands that we have are going to be our sebaceous and sweat glands. They are all exocrine glands, meaning they drain directly to the outside of the body. We have the hair follicles, and nails. So let's start with our sebaceous glands. These produce oil. This oil is serves as a lubricant for the skin, a natural lubricant. It also helps the hair from being brittle, and its mildly acidic nature also helps kill bacteria. Most of them empty into the hair follicles themselves, but others do open directly into the skin. And interestingly, they are not activated until puberty. Okay, so see these right here are sebaceous glands surrounding the hair. We have other ones again that drain directly to the outside of the body. They're found more towards the more superficially than the hair follicle that we see down here. We see a micrograph right here. So all of these cells right here, this is our sebaceous gland, and then the duct opens into the hair follicle, which is what we see right here. All right, so our sweat glands now, obviously, hence their name, they produce sweat. They are widely distributed throughout the skin. We actually have two different types. We have eccrine glands, which open directly to the skin surface, and then apocrine that empty into the hair follicles. Okay, so we can see right here our eccrine gland going straight to the skin surface right here, and apocrine would go into the hair follicle and then travel out the shaft where the hair follicle opens to the outside of the body surface. So sweat and what it does, well, it's mainly water. There's some dissolved salt, some vitamin C, some metabolic waste, and we find some fatty acids and proteins in our apocrine only. We should probably already know from chapter 1 that sweat does help dissipate excess heat. It does help get rid of some waste products, and also it does actually help prevent the growth of bacteria. It'll inhibit bacterial growth. And the smell that sweat can have is usually going to be from that bacteria that it's actually trying to kill. All right, so let's talk about hairs. Now, hairs are actually produced by the hair follicle. They consist of hard keratinized epithelial cells. They are very, very, very tough for their diameter. And then the melanocytes, the same melanocytes that we saw in our skin that give our skin pigmentation, they're found in hair as well. Okay, so when we look at a cross section of our hair follicle, we can see that we have our inner cortex right here. We have a dermal sheath, the skin surrounding it, the epidermal sheath right here, and then the matrix right here is where the hair is actually growing. So that means that the cells that are found at the end of a hair are the oldest, and then the ones down here at the base of the hair are the shortest. Now, ladies, probably some of the boys in here too, when you get your eyebrows done, you're trying to pull those hairs out so you don't have a unibrow. The reason it hurts so bad, you can actually see how this expands on the end right here. So that pain that you feel, not only are you pulling away the nerve fibers from the end of the hair, but also you have to pull it through the dermal and epidermal sheath that makes up the hair follicle itself, which is what causes that pain. So let's talk about hair anatomy itself. The central portion is called the medulla, which is surrounded by the cortex, and then the cuticle at the outside. This is the most heavily keratinized part. This is where our melanocytes are. They give it its color. So we've worked about the hair follicle. Now, associated with the hair follicle is the erector pili muscle that we introduced in the previous lesson. It'll pull the hairs upright when cold or frightened. So when your hair stands up, so to say, that's because of the erector pili muscle. And then, of course, the sebaceous and apocrine sweat glands that we talked about a few minutes ago. So our figure 4.7a gives a very simplistic diagram of our hair follicle, the hair shaft coming out, the sebaceous glands right here, the erector pili muscle, and then our dermal sheath right here. Okay, so this is an electron micrograph of a hair. You can see the keratin being around it. These structures right here, this is most likely skin that is found surrounding the hair. Okay, so your fingernails and toenails. So they are scale-like modifications of the epidermis. They are very, very heavily keratinized, and the stratum basal extends beneath the nail bed. This is where we have the growth come from. They have no pigment at all, which is what makes them colorless. So if you don't have your nails done when you press on them, they should turn white, and the only color that they're going to have is going to be from blood flow that's underneath them. That's it. So the different structures that we have the free edge, we have the body that's visible, the attached portion, what we generally call the nail. We have the root of the nail that's embedded within the skin, and then the cuticle is the proximal nail fold that projects onto the nail body. Okay, so this cuticle right here, what I see is with a lot of female students who get their nails done all the time. You got to be really, really careful with this cuticle. Okay, this proximal nail fold. If you scrape away that cuticle, that a lot of women will do when they get their nails done, it allows bacteria to get under this proximal nail fold and creates what we commonly call an ingrown fingernail or toenail. Okay, so this cuticle wraps all the way around in kind of a crescent shape, starting up here, coming down. It usually will cover up most of what's called the lunula right here, and we'll see the cuticle being removed and bacteria, dirt, whatnot getting under there, creating that ingrown fingernail or toenail. It's not actually that part of the nail is growing, underneath the fold of the nail, the lateral nail fold. Okay, so I'm sure some of you have probably had an incident where you've smashed your fingernail or toenail, and you end up with this dark mark, towards the proximal end of the nail. And if you watch it over time, it actually grows out and away. Well, that's actually those dead stratum basal cells that are found down here in the nail matrix, and as they grow away from the root of the nail, it's going to eventually grow all the way out, and then simply gets out here and is removed with the rest of the nail. So if you have any questions, make sure to email me at mr.tucker.schs@gmail.com or post it in the comments below.